Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. On our program today, we're going to be talking about networking. It's been a hot topic in the computer industry for years now. In general, networking means the ability to interconnect several computers so that they can share things like peripherals or software or even data. Our guests today are two leaders in this field, Michael Pliner of Sytek and Charlie Bass of Ungermann-Bass. Gary, our two guests are both involved in a specialized form of networking, I guess you'd call it, called local area networking, LAN. How do you define that? What is a local area network?
I guess ever since we've had computers around, we've been trying to hook them up to transmit data around back and forth. Local area network is generally used around an office environment. It's limited geographically to a smaller area. Usually it's owned and operated by a customer rather than being a commercial utility that's being used. Because it's limited geographically, the performance is normally a bit better than you'd find, quite a bit better than you'd find in some of the traditional network systems. We're going to see examples of how the local area networks are being used, and I think we've got a piece here that will show us an example of a local area network used in an office environment.
The kind of countertop computer terminal that is typical of modern offices has a built-in limitation. It talks only to a central computer, linking it and the other terminals to one body of data. An area network is a way to expand this system by linking several computers together to share information directly with each other. Still a relatively new field, networking allows an organization or community to connect its various branches into an integrated, decentralized resource. At Stanford University's Central Computer Facility, a library network gives researchers instant access to material stored all over the United States. Campus terminals can tap into the system through a single yellow cable that snakes through the campus like a silent subway line. Although a local network can operate cheaply along telephone wires called twisted pairs, the single cable systems, known as baseband and broadband, have more flexibility, a greater data rate, and even bring the tangle of wires and cables almost under control. There are a number of ways that information gets shared within a network: along the arms of a star, around a ring, or through a bus. Messages either get automatic priority or travel like tokens from one station to another. Of course, the real advantage of all this is to the user, whose direct access to multiple sources of information becomes easier and faster. Our guests today are Michael Pliner, president of Sytek, and Charlie Bass, vice president of Ungermann-Bass. Both their companies are leaders in the field of network systems development. Gary?
Well, we've talked about local area networks as being a specialized kind of reduced geography network. Charlie, what are the things that characterize local area network?
Well, I think it's more than just the geography, Gary. That certainly allows us to understand the problem and understand the technology, but we're talking about total connectivity between devices, and we're talking about peer-to-peer relationships, meaning we want to get rid of that central computer and allow all these devices to talk freely among themselves.
Mm-hmm. What sort of applications are we finding in an office environment that lets these smaller computers talk to themselves?
Well, one of the fundamental motivations is to share resources and to share information, meaning that we'd like to have a single terminal be able to talk to more than one computer, and we'd like to be able to have a user share a resource that he might ordinarily not be able to afford, or have access to data which is common, and so that we're sure of the integrity of that data.
Mm-hmm. Mike, do you have anything to add to that?
Yes, I share the same opinions. We see local area networks being used in the office automation environment. We also see the networks being used in the manufacturing floors, collecting data as well as being able to transfer data back to the manufacturing operations. We also see local area networks being used a lot for just general data communications utilities. The network becomes, in a sense, a communications utility like electricity is distributed within the home. terminals interconnected to many different computing resources. We also see that local area networks provide mixed set of services. For instance, on broadband networks, you can provide video, voice, and data on the same cable system.
You mentioned broadband. What is this concept of broadband and baseband and so forth? What is that technology all about?
The really distinguishing feature of broadband and baseband is the modulation technique. In a baseband system, you are directly modulating the cable with electrical signals. In a broadband system, you are using the same technology which distributes video, CATV video to the home. You use RF as a modulation technique, and you can use what's called frequency division multiplexing. That is basically stacking different channels of data or information or video on the cable, and they can run simultaneously.
So this kind of technology, you can get the data rates up pretty high. What sort of data rates would you expect to find in a local area network?
Well, you will find data rates that can range anywhere from 9.2 kilobits per second up to Ethernet type networks, which are 10 megabits per second. Most technologies can even carry data even faster than that. Broadband has 400 megahertz available to it. Fiber optics can go up into gigahertz ranges.
So we're getting significantly faster data communications than we'd find in, say, some of the traditional techniques that have been used.
That's correct.
Excuse me, how do you make a decision as to which of those technologies you use in a particular application?
Well, if I could answer, first of all, this concept or this argument between baseband and broadband has really dominated the media and the discussions on the technology for some time now. And I think for most people, they're now realizing that the two technologies are both have their strengths and have their applications and are probably going to coexist rather than one killing off the other or dominating to the exclusion of the other. But choosing between them is difficult. It's a matter of application. It's a matter of cost, and it's a matter of efficiency and exactly what we're going after. The principal issue in baseband is probably its simplicity, and that results in cost savings, and it results in savings of installation and ongoing maintenance. The principal issue in broadband is its multiple channels, allowing multiple applications, something that baseband simply can't do. And I would characterize broadband as being somewhat more complex and somewhat more costly. However, if you need that application, if you need that ability to transfer something other than a simple data stream, broadband is the only way to go.
What about some of the software issues that relate to supporting networking, local area networking? Are we looking at a lot of specialized software that's being developed to support, say, inter-office communication and mail, or are we developing operating systems and operating environments and tools that support a much easier programming environment?
Well, first of all, there is an entire set of specialized software related to local networks, which we typically refer to as the protocols of these networks. And in order to put these networks in place, it has meant that we've had to provide the software in the context of systems that were built without any knowledge of the network. So in many cases, we've added the software on to existing systems. Over time, I think you'll see that that software will begin to permeate those systems themselves. In other words, operating systems will begin to be built with the assumption that there's a network there, rather than the case today where we try to tack it on to the existing system. That has somewhat limited the application, meaning that we've had to compromise how we use it because it wasn't fully integrated. Over time, the systems will be built with that assumption, and we'll see a lot more application, a lot more power as a result of it.
Mm-hmm. Mike, are you seeing any integration of software function through local area networks, actually using the networks and the work that you've seen?
Oh, yes. And I agree with Charlie. I think the local area network vendor takes a lot of the software and moves that into the devices themselves. For instance, the device here, there is a microprocessor in that unit, and there's a significant amount of communication software. You will also see, as applications migrate to further distributed processing, sharing of files, sharing of electronic mail, that you will see specialized application software written to basically be resident in the host computers or the microcomputers that will connect on to the local area networks.
Is standards a problem in this area of local area networking? I mean, can you link up different vendors' hardware, different operating systems? Mike?
Well, excuse me.
Okay. Yes, you can. They do exist some standards today. For instance, the common standard that both Charlie and we actually adhere to is just an RS-232 connection. That allows us to interconnect many different vendors of equipment. That does give you some limits, though, in terms of performance, in terms of function. And there are standards activities going on right now within the IEEE 802 committee, with the National Bureau of Standards, which will derive a set of standards for the future. And both of our companies are participating in that.
Are these standards that are actually used to, say, intercommunicate between different kinds of local area networks? I mean, are standards really important if you're, say, have a vendor product where it's all self-contained in one geographic area? Is it really necessary to have those standards? Or do we look at standards for gateways, for example? Where do you see those standards actually being important?
Well, there's a lot of standards activity because we're talking about the interconnection of different devices, and the more common their communications are, the simpler it's going to be. However, we're starting with the fact that these standards aren't in place, and a big part of our job is to find the lowest common denominator, which Mike has mentioned, RS-232. It's not necessarily ideal for connecting networks, but it exists, and it's a well-established standard. But there are network technology standards themselves at the, if you will, the cable level of what kind of cable we're going to install and how we're going to share that. And most of the network activity has been around that set of issues. Those happen to be very low-level primitive issues compared to the entire problem. And over time, we're seeing attention being given to these higher-level problems so that once we can install the same cable and begin to share it, that in fact we can truly begin to communicate across that cable. We aren't there yet. And when we started this, a good bit of the industry thought and hoped that a single standard would emerge. That's clearly not the case. We're probably going to end up with a few dominant themes, and then we're going to have to figure out what the connection between those themes will be in the gateway technology that you talked about.
Excuse me, I want to ask you guys to demonstrate one of these network systems for us in just a minute. So while you get ready, we'll take a break, and we'll be back in just a moment with a demonstration of a local area network. Joining us now is Phil Edholm of Sytek, and Phil, you're going to give us a networking demonstration.
Yes, what we're going to do here is demonstrate on a small prototype network we've set up making sessions. First, I'm going to actually call over this network using this terminal to a host computer. And then when the computer prompts me for a login, actually log on. And I've now made a session over the network. The computer takes a moment to log us on, and in the interim, what I'd like to talk about is what we have here. We have a terminal, an asynchronous ASCII type of terminal, connected to a microprocessor-based packet communication unit. This unit incorporates a microprocessor, memory, and software necessary for all the layers of the protocol to allow communication over the cable, addressing, error recovery, retransmissions, etc. When the computer comes back, you'll notice we now have a session to a host computer, and by typing in something such as a system command, we can get a listing of directories on the computer. By typing a break, we're now back talking actually to the network, and we can do a status display. And you see now that we have actually one session over the network. With a network, one of the unique abilities is to have multiple sessions. Rather than just having one wire running from the terminal in one room to a computer in another room, we can literally have many wires running from that terminal, virtual wires through the cable to many different computers, and can turn them on and off. A very versatile technology supporting thousands of terminals on one cable.
Okay, that was an example of centralized intelligence. Now we want to see a demonstration of distributed intelligence. And Phil, what are you going to show us?
What we're going to see this time is a personal computer connected again into the network through basically the same type of technology, downloading from the same computer a file into the personal computer, and then printing that file out. So this time, rather than being at a dumb terminal, we have the ability to download a file, print it out, or work with it, and upload it afterwards. In order to do this, what we've done is loaded into the PC a program which allows us to communicate to the network, basically a terminal simulation. Again, we call over the network to the computer address, and then begin the login procedure to log on to the computer as we saw before. This is done, of course, to keep intruders out of the computer by requiring a password login into the computer, and then the computer has to respond to us. And this generally takes a moment.
So you're waiting to hear back from the host you're
From the host
talking
computer, exactly. And here it comes with a message of the day, basically telling us some information about the computer itself. And in a moment we'll get a prompt back from the computer. When we get that prompt back, what we're going to do is begin a procedure to get a file from the computer, which is a letter file, and download it into a file in the PC called letter.
So you're downloading now from the host.
Right, now the file's being downloaded, and there it's now complete. And now what we can do is get out of the download terminal simulation program and go back directly communicating to the PC by typing in a command, which you notice flips us back talking to the PC. And it's now possible to take that file that we downloaded and print it out on the printer. And we got to type it in again. And there we go. And now this is the file that actually was downloaded from the host computer, and is just a letter of a response to a customer. The interesting thing, of course, about this technology is that on the same piece of cable, this entire network is running over this type of cable, which is a 75 ohm coaxial cable. We can also have video. This is represented here. We have a small Walkman type of television set, which actually has the picture that's being transmitted out from the studio modulated on the same piece of wire. So a piece of wire that could support literally thousands of terminals and numbers of PCs and host-to-host computer communications can also support video and other types of systems.
Phil, let me ask you a little bit about this operation right here. This is a file transfer operation, what I guess I'd call a file transfer operation, upload and download. Is this typical of the kind of software that we're talking about in terms of communications over LANs, or are we looking at really a distribution of the whole operating system over that environment? I mean, ideally, we wouldn't want to have to make these file transfers, but we just access the file and it happens to be over the network, then...
In this case, the network is in effect communicating with the PC as a terminal, and the PC then is initiating over the network a file download procedure. And that involves a special piece of software, very small, in the PC to actually do the file download. The network communication, in other words, guaranteeing that the data is received without any errors, is actually in the network node itself.
But ideally, I guess in the long term, we'd like to have that operation completely transparent too.
Exactly.
Charlie, what is your response to that?
Well, I think that's exactly it, Gary. We have a case here of adding communications to an existing environment, and we're making the most of that communications. However, as you say, we'd like all this to occur transparently so that the commands that the user sees are very natural, and he has no idea exactly where the resource is, where the transfer is taking place. It happens because of the underlying mechanisms and not because he explicitly requests it.
And this comes back to the original comment, I guess, that we made about integration of the local area network into the software itself. Is that true?
Right, which over time will happen. I mean, the next generation of these devices will assume a network, and these things will happen much more naturally than we've seen.
We talked earlier about standards in general, and if I recall, Xerox and Intel and Digital Equipment Corporation had a standard they were proposing. It was called Ethernet. And what's happened to that? It's been around for a while.
Well, it's, in some terms, could be declared very successful in that a number of companies have endorsed it and people make equipment according to that standard. I think a couple of things, however, have to be said, and one is Ethernet is not an end-all in itself. It represents a basic technology that aids in this problem. And secondly, it's not the only technology that's going to be applicable. We're seeing an example here of broadband technology, which has its own attributes and is an alternative to Ethernet.
So if we take a look at local area networks in general, it seems to me that over the last few years that we've heard the talk about local area networks, that maybe one of the things that's caused difficulty and acceptance is a standardization of the interface. Is that true?
Sure. The fact that, again, we were looking for something that would solve all the problems and we aren't going to find it. It's like the universal computer. There isn't one, and we probably wouldn't be happy with it if it existed. It'd be a Turing machine, probably.
Right.
All right. I think standards come in time. To try to come up with a standard too soon would mean that maybe we would standardize on the wrong thing. We're seeing a lot of activity now with Ethernet, with broadband in the standards communities, as well as token passing for manufacturing and manufacturing automation requirements. And their whole question is, what will IBM do? And that itself will set a standard for the industry.
IBM.
Gentlemen, yes, we're out of time on that note. Thanks very much for joining us, our three guests and all of you, and hope you'll be with us again for the next edition of the Computer Chronicles. Random Access is made possible by a grant from Byte, the Small Systems Journal, publishers of a monthly magazine on microcomputer technology and innovative projects in the world of computing. In today's Random Access file, have you always wanted to get into the stock market but never wanted to deal with those stockbrokers? Well, if you have a personal computer, you can buy and sell like the big boys now and never have to talk to a broker. C.D. Anderson, a small discount broker in San Francisco, has announced the first home brokerage computer system. For an initial $300 fee, you can use the service to place an order for almost any kind of investment transaction. And Charles Schwab has also announced plans for starting a home computer brokerage service beginning early next year. The computer invasion of the public schools is continuing, but amid new controversy. Latest figures are that 86% of all high schools have at least one personal computer for student use, and 61% of all elementary schools now have at least one computer. But educators are starting to argue over what to do with the computers. Some experts are saying it's a waste of time to teach kids programming. Others are saying that most computers in schools are now being used simply as electronic flashcard systems. The job of getting enough computers into the schools is monumental. One research firm says it will cost $4.5 billion to adequately equip America's schools with computers. And the value of it all is still not clear. In one study, 69% of the students tested knew how to draw a 90-degree angle on a computer, but only 19% of them knew how to draw one on paper. A Stanford study just released shows that boys are much more interested in computers than girls. The vast majority of students enrolled in computer camps are boys, as is the case with computer ownership and the purchase of computer games. The Stanford study says that could create real problems for women in the workplace of the future. IBM and Hitachi have buried the hatchet, reaching a settlement agreement in their stolen trade secrets case. Hitachi reportedly will pay IBM several $1 million. Hitachi has also agreed not to use any of the information it obtained and to return all stolen documents to IBM. Hitachi also agreed to disclose the names of anyone who offered to sell IBM trade secrets to the Japanese computer company. Industry experts are hopeful this settlement formula will set a precedent for resolving future trade secret cases. Well, AT&T says it's getting into the information business, and it sure is. AT&T just announced the sale of a $70 million information system to the Japanese phone company Nippon Telegraph and Telephone. AT&T's computer software system will be used to monitor Nippon's communications traffic. Nippon also plans to buy a $12 million Cray computer to run the system. The whole deal depends, however, on approval of an export license. News from the executive suite, more top management changes in the Valley this past week. 2 top Atari executives have quit. John Cavalier and Jeffrey Heimbeck have left their positions in Sunnyvale. Cavalier moves to Apple, and leaving Apple is John Couch, the man behind the Lisa project. Couch joins the board of Software Ventures, Inc. of Mountain View. Couch says he wants to push the technology of software 4 or 5 steps past Lisa. If you're confused by all the new computer books coming out on the market, there's good reason. The publishing industry says there are now 2,000 computer how-to books in print, and that computer books are outselling all other business-related books. In fact, Crown Books says the growth in computer books is matched only by the growth in romance novels. Last year, more than 7 million computer books were sold for a total $30 million in sales. And the story's the same with computer magazines. There are now 72 monthly computer magazines on the market, and this is a business which didn't even exist 6 years ago. Last week we took a look at the best-selling business software. This week we'll check the top sellers in computer game software. The top 5 in order are Zaxxon from Datasoft, Wizardry from Sytek, Flight Simulator from Microsoft, Pinball Construction Set from Electronic Arts, and Zork 1 from Infocom. Finally, it had to happen when Sweet Lady signed on to CompuServe's CB channel. Little did she know what was in store. She met Mr. Mike, who helped her figure out how to retrieve electronic mail. Mr. Mike and Sweet Lady then moved to the private talk mode, and wouldn't you know it, last week Sweet Lady and Mr. Mike got married on the CB channel, of course. The whole ceremony took place on CompuServe with more than 70 invited guests logged in, and when the minister entered the words, "You may kiss the bride," Mr. Mike typed in KISS. Now that's networking. And that's this week's edition of Random Access, a capsule look at what's going on in the world of computing. Watch for Random Access each week immediately following the Computer Chronicles. Random Access is made possible by a grant from Byte, the Small Systems Journal, publishers of a monthly magazine on microcomputer technology and innovative projects in the world of computing.